Hey everybody, how's it going? So I realized that last week we talked a bit about naming compounds and names that come from the formulas. So today I'm going to talk a little bit about how we can figure out the formulas from the names of compounds. I'm going to start with covalent compounds because those are pretty easy. The formulas are basically outlined in the name already. And I've just written down a few examples. So the first one is phosphorus tribromide. So remember, with the first element, if there is no prefix in the front, so like di, tri, tetra, so on, that means we only have one of those, which means we're just going to have a single P. Then we have bromide, which comes from the element bromine, which is Br, and the tri means that we have three of them. So from the name phosphorus tribromide, we know that's PBr3. Here's another example, dinitrogen pentoxide. So we have nitrogen, which is N. We have the di in front. Di means that we have two. And then we have pentoxide. So oxide is O, and the penta means 5. And then one more example. I think we did the reverse of this one in the naming video. But we have carbon. There's no prefix for carbon, so that's just a C. Hydride is hydrogen, so that's H. And the tetra means we have 4 of them. So remember, the prefix only goes with the element that it's with, and we write the number after the element in the formula as a little subscript on the bottom. So now ionic compounds might be a little bit more complicated, but we're going to talk about something called the crisscross method. So let's take a look. Alright, so we're going to talk a bit about how to name ionic compounds now. I just wrote a very quick periodic table. This is just the elephants, the elements that are on the left and the right side. So I didn't include any of the middle ones. So these are the elements that we've pretty much been working with the whole time. And we're going to learn something called the crisscross method. I'll show you what I'm talking about in a moment. But first of all, I'm just going to say the elements here in group 1, the alkali metals, they have one valence electron that they want to get rid of. So when they get rid of it, they have a charge of +1. These elements here in group 2, the alkaline earth metals, they have 2 valence electrons to get rid of. So when they get rid of those 2, they have a charge of +2. Similarly, these ones are +3. Now these ones here, they can sort of go either way. We saw that carbon makes ions that have 4 valence electrons, so they tend to make 4 bonds to do covalent. But I'm just going to write here plus or minus 4. And then these ones here, they make ions of -3 because they're nonmetals, so they gain 3 electrons. These ones here, they have 6 valence electrons, so they need to gain 2 more, which would give them a charge of -2. These ones here, they only need 1 valence electron, so they would have a charge of -1. And then the noble gases on the right side, they don't play any role in ionic bonding. I just wrote these ones here just to complete the table sort of thing. But yes, they would have a charge of 0. So how can we use this information to name ionic bonds? Well, if we take, for example, sodium chloride, and remember sodium chloride is NaCl. But how do we know that it's NaCl without drawing the diagrams? Well, we know that sodium has a charge of +1, and we know that chlorine has a charge of -1. So what we do is we write the charges on top, and then we take these charges and we crisscross them over to where they would go on the bottom. So we would write them on the bottom, but without the charges. So it would look sort of like this. Na1, Cl1. And remember, in chemistry, just like in math and stuff like that, we don't have to actually write the ones. So it would just be NaCl. So this is a more basic example. But what if we did something like aluminum oxide? So aluminum is Al and oxygen is O. Now if we look in our table, aluminum has a charge of +3 and oxygen has a charge of -2. So if I write those into the table, +3 and -2, and then I take them and I crisscross them over like so, we can find that the formula for aluminum oxide is Al2O3. I'm going to do one more example. Let's say calcium sulfide. So I guess I'll just write the name here. Calcium sulfide. So the Ca is calcium, the sulfide is sulfur, which is S. Now calcium here has a charge of +2, and sulfur has a charge of -2. So if I write them in here, I would have +2 and -2. And then I'm just gonna crisscross them over like so, and we get Ca2S2. Now I don't remember how well you might remember things like reducing fractions. We can do the same thing with ionic compounds. So instead of Ca2S2, we can divide both of these by 2, and we would just get CaS. And that's because if we were to draw the ionic the Lewis dot diagrams, we would see that we only need one calcium and one sulfur to take place in its bonding, like so. So we only need one calcium and one sulfur to make calcium sulfide. So if you guys have any questions, just let me know. There isn't going to be an assignment about this, but it's going to be important to know for future chemistry if you decide to take chemistry in grade 11 and grade 12. But if you have any questions about any of this, just let me know. All right, guys, have a good one. See you.